This month, NASA's Europa Clipper spacecraft will launch on a mission to find out whether the icy moon of Jupiter could be a good place to build our second home. But before we get there, we have to figure out how to drill a hole through miles of ice. Welcome to my channel. It's me. And today we're talking about Europa, the frozen moon of Jupiter that might also be an ocean world. Europa is the smallest of the 4 Galilean moons, discovered by Galileo in 1610. Its diameter is only about a third that of Earth's, and it has a mass less than half that of our moon. But don't let its size fool you. Europa is actually Earth's best candidate for off-world colonization. At least that's according to some planetary scientists. Scientists think that Europa may have more water than all of the water on Earth combined. Europa has a rocky core, a mantle of ice, and a crust of ice up to 15 miles thick, that's hiding a global ocean of liquid water, potentially containing more than twice the volume of water than all the water on Earth. This is because the tidal flexing from the gravitational pull of Jupiter and the other Galilean moons generates enough heat to keep a massive ocean beneath the ice. But here's the problem. To get to that water, we need to drill through at least 15 miles of ice, which is over 20 times the thickness of the Antarctic ice sheet. In fact, we've never drilled anywhere near that far into anything. The deepest hole ever made by humans, including on Earth, is just under 12 kilometers deep. That's called the Kolyma Super Deep Borehole. It's located in northwest Russia and was drilled in 1970 during the Cold War, when scientists needed to understand the properties of rock deep inside the Earth. The project was abandoned after they reached a depth of 12 kilometers, or 7.5 miles, due to temperatures reaching 180 degrees Celsius or 350 degrees Fahrenheit. That's as hot as molten lava. So it goes without saying that drilling a hole through Europa's ice crust would be pretty challenging. NASA's Europa Clipper spacecraft will attempt to answer several key questions about the moon, including how much water exists on Europa and if that water could support life. However, it won't actually land on Europa or drill through its ice. Instead, the spacecraft will fly by the moon more than 40 times over the course of its 2-year mission. During these flybys, it will take high-resolution images of the surface, measure the composition of the ice crust, and search for water plumes erupting from the surface. Scientists hope that one day they can use data like this to plan a crewed mission to Europa that could one day become a permanent human outpost. So what are some ways we might drill a hole through the icy exterior of Europa? First, we need to know more about the structure of the ice itself. Is it solid all the way through, or are there pockets of liquid water within it? Will it be more like drilling through a thick layer of snow, or more like cutting through a block of ice? All of these questions are important for determining what technology will be required to drill through the ice. One possibility is using a hot water drill, similar to those used on Earth. A hot water drill works by forcing hot water into the surface at high pressure. This melts a small hole, which is then widened using a drill bit. Hot water drills are currently used on Earth to drill through permafrost and other frozen ground, though they're also used in some offshore oil drilling operations. Hot water drills have been proposed for use on Europa because they're relatively simple and efficient. Plus, the water used in the drilling process could be recycled and used for drinking and other purposes once it's purified. Also, since we expect Europa's ocean to be salty, similar to Earth's oceans, the salt content in the water should help lower its freezing point, making it easier to melt through the ice. However, there are challenges associated with using a hot water drill on Europa. For example, the intense radiation from Jupiter would likely damage the electronics and plumbing of a drilling rig. Also, the water used in the drilling process would quickly freeze once it came into contact with a cold space environment. Therefore, the drilling rig would have to be designed in a way that prevents the water from freezing, perhaps by circulating it through a closed-loop system with a heat source such as a nuclear reactor. 2. Another option is using a mechanical drill bit, like a giant ice auger. Mechanical drills have the advantage of not requiring any hot water, which would simplify the design of the drilling rig and reduce the amount of equipment that needs to be sent from Earth. However, they're also less efficient than hot water drills, meaning that they would take longer to drill through the ice and require more energy. Additionally, the moving parts of a mechanical drill could be vulnerable to damage from radiation and micrometer. There's also the possibility of using a combination of both hot water and a mechanical drill bit. For example, A hot water drill could be used to make an initial hole, which could then be widened using a mechanical drill bit. Ultimately, the best approach will depend on a number of factors, including the exact composition and structure of the ice, the amount of radiation, and the duration of a typical drilling operation. It would also be helpful to learn more about the internal structure of Europa. The thickness of the ice crust could vary depending on where we drill. Some scientists believe that the ice crust could be as thin as 15 miles in some places and as thick as 25 miles in others. Additionally, the temperature of the ice could also vary depending on where we drill. The subsurface ocean could be kept warm by tidal flexing, but the ice above it could still be very cold. Therefore, the drilling rig would need to be able to operate in a wide range of conditions. If we were going to drill a hole through Europa's ice crust, we would need to develop new technologies to help us do it. For example, we would need to develop new materials that are strong enough to withstand the intense radiation from Jupiter and also resistant to the corrosive effects of salt water. We would also need to develop new ways of generating power in the harsh environment of Europa. Aside from radiation and corrosion, another big challenge is keeping astronauts safe. Any drilling operation would involve sending astronauts into the frigid vacuum of space to work on the drilling rig. They would need to wear special spacesuits to protect them from the cold and radiation. And we would need to develop new life support systems to keep them alive while they reworking on the rig. Also, if something went wrong and the astronauts needed to evacuate, they would need a way to get back to their ships safely. We would need to develop a reliable and safe means of transportation between the drilling rig and the ship. The thought of drilling a hole through the ice on Europa seems like a daunting task, but it's not impossible. With careful planning and engineering, we could develop the technology needed to make it happen, and the rewards would be worth it. Access to Europa's vast ocean could provide us with a wealth of resources and opportunities for scientific discovery. It could also provide us with a backup plan for humanity in case something happened to Earth, whether it's a natural disaster or a man-made catastrophe. Having a second home on a distant moon could be a lifesaver, literally. On September 22, 1962, President John F. Kennedy addressed the United Nations and outlined his vision for the future of space exploration. He challenged the world's scientists and engineers to come together and put a man on the moon by the end of the decade. Just 8 years later, on July 20, 1969, Neil Armstrong became the first human being to set foot on the moon. The Apollo 11 mission proved that it was possible to achieve seemingly impossible goals when nations and people come together with a common purpose. So what do you think? Is it possible to drill a hole through the ice on Europa? Let us know your thoughts in the comments below. And don't forget to subscribe so you don't miss out on future videos. Thanks for watching. I'll see you next time.